Good. So you've heard a bit on epidemic intelligence, public health intelligence. So before going into how AI has been helping in this work, I wanted to briefly explain you more or less what is the process. So the key thing here is that we are dealing with public data. Most of the time it's not validated, it's coming from news. So the first step that we have is actually to screen different sources, not only open sources, but also we have restricted platforms in which different public health institute, national and global level will share any signal that they may find. One example that I always share with this unfortunately coming pandemic, 31st of December 2019, one of our members of the team was on duty, so he was just screening these sources and found one article in ProMed saying, look, there are 25 cases of unknown pneumonia in Wuhan. He went to check, found the official information from the Wuhan authorities, of course in Chinese, so that's also another challenge that we have on a daily basis, the languages, because it's not only Europe, it's anything that may affect. And then started with a different validation, checking whether it could be of interest, and communicating. So as you see, it's a process, you see it linearly, but actually it's more on a cycle base. So we will start with our screening, we will check all the information that we've gathered, and we'll hear more about how new tools like EIOS is helping on this task, and not only. And then we'll try to see what is of interest for us. So of course, in our case, we are mainly focused on human diseases that could have an impact on Europe, which, as you can imagine, is not really only Europe. And then we'll validate the information. Dealing with open sources, that's one key thing. We need to ensure that there's no false information, because when it comes to misinformation or even disinformation, it's actually more difficult trying to correct the information than just filter it in advance and ensure that you are not sharing. The analysis of this information is also really important step, because we need to share and communicate with our network. So we need to give them a bit of the who, what, and where, and when happened, so they can follow up on this. And then there will be different type of signals, things that may just stay as a signal and will not go further, things that would be more of an immediate threat. So imagine that during the outbreak of Ebola in Western Africa, we found a case in Europe that would be different than just saying, well, it seems that there's a food that has some contaminant, maybe someone can get sick. So there are different levels. And of course, before tools like EIOS were there, as Daniela was saying, we were screening different sources, which meant that we had to go to the different platform, check for the information with the different structure, different metadata, and validate. So it took a lot of time, because just going from platform to platform with the different goods and bad, it will be really complicated, and it didn't have some of the aspects that actually these new tools are bringing. So on that regard, I would like to start with the first question to Stefan. So as Daniela mentioned, the World Health Organization, in collaboration with the Joint Research Center at the European Commission, developed this public health intelligence system, the Epidemic Intelligence from Open Sources, EIOS, to detect any potential health threat and help us a bit in this context. So can you explain us a bit more what is the system and which are actually the AI components on it?
Yes, thank you very much, Laura, and thank you everyone for being here. So I will tell you about EIOS, but first I will tell you about the hub in Berlin. So the World Health Organization, I think you know all about it, but since 2 years there's a new branch of the headquarters in Berlin, which is called the WHO Hub for Pandemic and Epidemic Intelligence, and our job is to support member states, organizations for better public health intelligence. And that includes helping gathering better data, doing better analytics, and taking better decisions. So that's our motto. And there, of course, data and analysis play a central role. So within the PHI workflow, we heard about it. We try to support this work by analysts, and one of the tools is EIOS. So EIOS is two things. It's a community of practice, and it's a software and a system. So the community of practice, we do training, we support analysts everywhere to set up what we call sometimes event-based surveillance, so this screening of events, okay, what's going on in the world, what is relevant for me, and there are processes and the kind of work you showed, we help people set that up. And then there's the platform, the software, which we see here, a screenshot of the website, so people can register. It's not for everyone, only people who are partner with us, but any member state, for instance, could join. And here, what you see is on the left, the panel for settings, and on the right, your feed, essentially. And the settings are what you are interested in, and the feed are articles that are scraped online, so websites, texts, from sources that people have told us might be interesting. So this is a curated news feed, if you wish, of handpicked sources. And then any analyst can say, I'm interested in that diseases in that region. And here you see the map. Just a word about the community. We have trained more than 100 communities. So a community is like a client, if you wish. It's a member state or a group of analysts. And more than 3,400 analysts have been trained on the platform. So here, in terms of AI, what we already have in generic terms are the named entity recognition, and in particular the geotagging you see here. So you have a piece of text, it could be in a news article, for example, and the system will say, okay, this is about these topics, so which are extracted, and these are the countries concerned. And then you can see it on the map, and you can say, I'm interested in the European region or the African region, and so on. And then it's one way to filter the information. This is a challenging aspect. We discussed that, especially in geotagging, to remove the ambiguity of the words, and this is where we hope in the future to do better with the language models, which can take more context into account. We have translation, at the moment to English, but of, I think, 6 languages to English, and then for all articles in English, we have a summarization, so abstractive summarization that takes the full text, and those are small summaries, so people can quickly screen the articles. And the last bit that we do not have anymore was, for some time, disinformation. So it was before I joined, but colleagues during the pandemic, and we heard about it, so disinformation, misinformation was a big issue, and you have what some call the infodemic, that there's too much out there, even too much good information, you know. But so we tried, or my colleagues tried, you know, to have a classifier for, okay, this might be disinformation or not, and it didn't work well. So it was shut down, of course, when they noticed, because it is also a very difficult topic. Just a word on that. Scientific articles would be, it was trained on a public data set of news articles. Scientific papers were identified as disinformation because, of course, in terms of style, they were very different from news articles, you know. So these are difficult topics, and we'll talk more about that, I think. Maybe a word here on the future AI ideas for this system. One that our colleagues in a joint research center of the European Commission are working on is a recommender system. So you have different users, different communities of users. They can interact with it. And maybe I should say a word here that not only can you screen, but you can interact with the article. So you can pin, you can flag it like a like, if you wish, on Instagram. And you can communicate within a community. So Laura's team, they can exchange, comment on articles, write themselves messages, and say, look here, I have pinned that. And within the community, they can see what others of their colleagues have pinned or flagged. And so one approach is to say, oh, but here there's a lot of information. We can use that to inform other communities. Say, look, some find this interesting. Maybe this might be interesting for you as well. So that's one project. One other project is noise reduction. So I said all the sources are curated, but still there are tens of thousands of websites which are scraped. They are not all relevant for everyone, and not everything that's published there is relevant for everyone. So you can filter what you see, but it's quite rough. So one project we have with the Roback Institute in Germany is noise reduction. Say, for you as a user, this might not be relevant. So we don't remove that from you. You can still see that if you want. It's a bit like spam, you know. But has to be very specific, because what is relevant for one community might not be for the other. Quickly to finish on what we are working on, summarization, we want to go towards topic modeling and topic summary, so to have an overview of what's going on, but that might interest you. semantic search that you go into the system. So you will have, all this is a huge database if you want, that you can query it in a smart way if you wish. And the last part are smart categories. So I didn't explain how it knows that about certain disease or certain type of events. At the moment, it's really much keywords-based, string matching, and we want to go to something that's more, smarter. Thank you.
Thank you so much. Just a word also, I forgot to mention, this platform covers not only infectious diseases, it has all type of diseases, also disasters, human, animal, so it's really a huge amount of information that can be used in different contexts. Thanks a lot for this overview.
Thank you, and please, if you have any question, feel free to go on Slido, and I see already some questions coming in, so please keep doing that. I now have a question for Roberto. So you and your team have been working with the Istituto Superiore di Sanità, the National Italian Institute for Health, to really explore the use of AI tools to improve the quality and effectiveness of the work done by the Network on Epidemic Intelligence, which is a distributed network across Italy, to really support the analysts by automating the process of applying machine learning entity extraction work that also Stefano was mentioning they do with news, and also use the generative AI. So it's a lot of work, and we would like to know more. And if you can tell us about the steps and the kind of methodology that you have been using.
Okay, thank you for the kind invitation, and I think it's perfect, this organization, because it is happening that with the Italian team for epidemic intelligence, we were just observing the way they were using these platforms, and then we discovered that most of the burden is on the analyst. I mean, it has to decide the precise keywords or focus of their own analysis. They need to pose queries and they need to read and judge. And that's fine. I mean, that's the prevalence of the human knowledge on this very complex task. But because we are an AI community, so we would like to increase the level of support coming from the machines. So I just try to give you an idea about the possible methodology. First of all, we would like to improve the monitoring of the web news because, you know, the keywords or the focused topics may be a restricted set of terminology or terminological entries that allow matching in the web. But in order to do some more, we could make our system do crawling that is first keyword based and then is expanding the keywords autonomously. So at very first generative AI possibility is try to model the semantics of keywords through modern methods of language processing. Then these tools are able to download from the web sources, make available this news through complex indexes and support the querying and navigation of the expert. In the second step, all this huge material is a very big asset with respect to one team focus. If the team has been focusing on some topics, then the abundant set of noisy documents that they have is a big asset to discover what's going on in these topics. So what we do is try to support the matching of novel aspects, novel events that may arise from the news streams. And so what we do is we try to go in the text and find out possible meaningful patterns, linguistic patterns that are dealing with specific events. And if the patterns are enough novel and enough frequent in this text, they can be used to produce some evidence about novel events to the analyst. Of course, these events are data-driven, so they are emerging, so they are not perfect. And the analysts are requested to look at them, simplified through semantic clustering of these events, and then to validate. So reject some of them and point to others. And maybe refine with more linguistic descriptions that the analyst can enter. Finally, the system is able, given the evidence of novel events, to provide an image of what these events mean, and so use them to go back to the news that have been formally downloaded according to general principia, and try to make more specific, event-specific filters. And so they can start classifying the news and reorganizing in more specific categories. So this is done by the zero-shot learning capability of language models, and in the zero-shot learning, the accuracy is not very good. I mean, it's an exploration that is made possible by generative AI. But at the very end, by interacting with the news, not only with the linguistic patterns, but the news themselves, the analyst can accept, like, I like this classification from the early system, or reject some classification. So during the interaction, the team of experts are developing specific examples of the individual categories. And at the very end, through fine-tuning, supervised classification of the language models, then we can have very specific categories learned by the system that is able to add this metadata. All this method is run by specific teams. So the information is collectively analyzed, validated, and then shared among teams of experts. Just to give you an idea, the very first stage is the simple way of querying what has been downloaded by the system. You see there that the system is providing recommendation for the query formation. And the recommendations are due to the fact that a very specific linguistic capability is to generalize terms and try to stipulate a matrix of similarities between terms. So during the querying, in a very health-specific policy, the system is able to recommend a way of querying. And so every query is activating a number of categories. Sorry for the Italian, because we were mostly measuring for Italian text. But on your left, you see that every individual text has been organized according to the events or topics that have been requested in the early phase of crawling by the analyst. So a query is a snapshot of the taxonomy of topics. And on the left, you have the taxonomy triggered by the query. When you read this query, you can accept and reject, but basically this is the large set of document. I mean, during the last 5 years, for the set of terminology that has been used by the ISS institution in Italy, we were able to download something like 300,000 different news, very much focused on a couple of campaigns, that was COVID and something more. So this is a huge amount of information that we would like to exploit in the next steps. And the next steps is called event detection. So I can filter with some new terms the set of documents we get, and during this stage, as you see, the system is studying possible patterns like some of the patterns that you see on the left, like chikungunya, trasmettere an hop, that is something relating a verb like transmit to some concepts that are regular enough in the text, and they are specific to specific events that could be an health set of events like taking care of a pathology, but is mostly related to even daily events that in schools or in the communities, in the newspaper, are talked about, and they can be novel kind of situations where the relationship between pathology and the community daily life is relevant to be signaled. And the analyst is faced with this number of patterns that are clustered, focusing on specific events. And this event, as you see, is named automatically by the language model. The language model is looking to the linguistic patterns, is looking to the document, and is giving a name to individual events. And so these names are explored, and what you see here is just a query like, okay, I have this cluster, but let me see an example of a document of news talking about this event. And so these clusters are accepted and validated. After validation, then the system can start looking to the different clusters that you see in the bottom, try to start classifying automatically the news. And so we can tag the news with these new categories. And the system is giving examples picked up from the retrieval engine that takes the news and the semantic interpretation of this news in the light of the novel events. And you see here in green and red the possibility of the analyst of accepting, I agree, or rejecting the individual statement. The individual statement are something like this news belongs to this new event, these new clusters, with a specific confidence. So the system in zero-shot learning fashion is not only able to suggest classification, but give you some relevant score. And given the score and given the acceptance rate by the analyst, we assume that the system is able to bootstrap with the analyst and collect correct precise example of the new cluster. So I have introduced new events, and now I have some instances of news that can be correctly classified with these events. And this can be starting a fine-tuning that we later on assume to get the same classification of the entire data set in a more specific and accurate manner. So this is the overall, and it's really an attempt to say there is a team. It has a very good knowledge, it is interacting with the news, and the emergence of the new kind of phenomena is suggested by the system and is validated and refined by the analyst. And it seems a good kind of interaction. I think this is...
Thanks a lot for this overview, and to see, like in real life, how this can be integrated. And as you mentioned, it has been said, to support our knowledge, not to cover the lack of that knowledge. So I will put again this QR for those that join late. We see that we have some questions already, so thanks a lot. You can either scan the QR or go to slido.com, #AMLD Public Health. So thanks a lot for that overview on all the hard work and validation with the users. So Stefan, you mentioned that you have been training several teams, a huge amount with a lot of users worldwide on how EIOS can be used, but not only in collaboration with other partners like the European CDC, how these activities can be improved using such a public health intelligence system. But I can imagine that these users are quite different. They have different requirements and expectations especially. So can you tell us a bit how to tackle this and how to ensure that all these different expectations from different users are being met?
Yes, thank you very much, Laura. Yes, indeed. So EIOS system is a product, right? And we heard 2 days ago in another track, in our domain, the product mentality is not very strong. So we tend to try and produce tools, but not really think in terms of product management. But they are. And the best practices are, of course, if you want to be relevant, to go to the users and see with them what are their needs. Not that they tell you this is how you should do it, but that you understand the workflows and where you can intervene. So this is just best practices. And as you say, there's a huge diversity here. So what we do is, indeed, we engage. We are just starting now to introduce these practices of interviews, of following, recording how people work with the system and where we can intervene to be best relevant. There's something also we are working on, or we hope we can start soon in terms of AI, is actually related to what you showed. relevance scoring in a supervised learning manner. So something that we explored a few years ago already in another context, that when you screen and you find a signal, something that's interesting, it is typically stored in a database somewhere. So this information is very valuable, right? In terms of machine learning, that we say, okay, from the past, what was interesting for you in the past, can the machine learn to recommend or to detect relevant events for you? And those databases are automatically tailored for your needs, right? Because you produce that yourself. So this kind of rich knowledge that's routinely produced during routine work is very interesting for us. And I mentioned noise reduction. Also here, our approach would be for not to have what we had for this information, a kind of blanket classification, but to go to the users and say, can you label data sets for a few shot classification? So start maybe with a standard data set or with one large model, fine-tuned, but then go and adapt it to specific communities. So that's the kind of typical, I would say, product development problem. But we try we start engaging really with users in a broader way. And here I want to mention, but I think specific issues of public health intelligence in regard for AI, and why the users here are key to approaching that. So, and this is also something I should say that I would really much like to hear from all of you of your experience, because this is kind of new also for us. I think many of you here have more experience in terms of AI products. So if you have ideas also or recommendation comments, please also don't hesitate. And one more point, we are hiring at the hub, so please have a look. And we are really eager also to collaborate. Also, please don't be shy with the industry. You know, we are not like industry is bad or anything like that. We are really much interested in know-how, knowledge. So please don't hesitate also to reach out. So what I wanted to say about the specificities of AI for public health intelligence, we heard a little bit. I think there are a few points which distinguish from typical use cases from the industry or commercial aspects. So we have very complex data first. So we have all kinds of data. So we heard a little bit about that. But when you screen all these sources, you have text, images, emails that you receive from someone, phone call, a map, a graph, all this that you as a cognitive being synthesize in your head. So this is much more than just like text or just images that would need to be classified. Many of this data and the data you produce are sensitive. So you talked just between us earlier, those signals you identify, you don't share it immediately, right? You wait a little bit because you don't want to create a panic and so on. So this kind of sensitive data, again, are not like quality control in a factory where there are no data privacy issue or risk of communication. We work with sometimes vulnerable population, and we heard in the keynote yesterday evening also these very sensitive issues of, it has to work for them, it has to work on the ground, and people have to own. So something I like to say that's compared to, we are iOS kind of platform, social media if you wish, but compared to Instagram, Facebook, X, we don't want to own the users, we want the users to own the platform, but it also means that we cannot impose solution, and we have to think about what works best for them. And for the example of recommender system, I think we need to be careful, because this is something that Amazon would do or X, but their goal is very different from our goal. They want you to spend more time on their platform. They want you to buy more, to click more on ads and so on. We want our users to spend less time on our platform. So we don't want to overwhelm them. So if we recommend something, we need to be sure that, I think one of the fears, and when we talk also with users, they say they don't want to miss anything. So it's really overwhelming, exactly, because the biggest fear is to miss the event that will be then problematic. So we don't want to overwhelm. So that's why I chose noise reduction rather than recommending. I think is for me a good approach. We are a health institution, so we have to think in terms of mental health and environmental health. So when choosing a model, if we were to use GPT, I cannot ignore the conditions in which it was trained, you know. So we all heard about the ethics of, you know, the people labeling and this reinforcement learning. You have abysmal conditions in factories of people who label the text or the images to train the models. We cannot ignore that as a health organization. And the same with environment, right? The water resources consumption, the energy consumption. We cannot say, okay, this is fine to use all that power there and all these environmental costs, and at the same time say the biggest challenge is climate change and so. So we need here also to be careful what we use and what we validate. We need to be very precise in terms of the evaluation, the assessments, and very fast, so I said, right? The risk is to miss an event. Especially in infectious diseases, especially those that are transmitted between humans, they are exponential processes. If you are a little bit earlier, you can make a huge difference in those. And this is also one peculiarity, I think, of public health, infectious diseases in particular, this risk asymmetry. If I say next week there will be a lot of COVID cases in my city and there are none, it's not the same cost, as I say, there will be very few cases, but there are many, because then the cost is huge. So this was all this discussion we had a few years ago, right? But this is not like, again, quality control in a factory where you would say it's good or bad, but you will have your accuracy and will be, you know, kind of symmetric in two directions. And two more aspects I would like to mention. One is we have very diverse communities also in terms of rules and laws they follow, right? And even the ethics are very different for the different countries. And we as an organization, we do not say, we don't sit on top, we try to coordinate, but you at ECDC or the individual countries, they have their own criteria. And we need to adapt for that. So we cannot impose like one model which will work for everyone. It's true for values, for ethics, for criteria of evaluation. And the last point is that, again, the COVID pandemic, we saw how important this daily briefing, I think from Dr. Tedros, for instance, or from Mike Ryan, were that the fact that people say, we are the expert, we are on top of this situation, we are following, this in itself, this performative work is very important. But in reverse, if people start not trusting what is said, or they say, oh, he's just reading from a prompter that an AI has generated, and I don't trust the AI, well, then we are losing the most important thing. And again, here, this is where we cannot be too, you know, we need to be very careful, because once we lose this trust, it's very hard to regain. But at the same time, of course, we want the best for the health and global health, right? So we want to innovate. But we cannot just try and say, okay, we've tried, it failed, because then we lose our most important assets. Right, and in that way, to conclude on the users' involvement and on AI, I think we need to involve them to create this intuition of what AI can do, and for them to tell us their own requirement, how to function. And for that, one other thing I would like to do as the hub is to offer kind of sandboxes. Say, okay, here, let's do a kind of workshop, see how it works, how it can work for your own workflows, and then take it from there and follow with them. Thank you.
Thanks a lot. As you can see, we are reaching the point where actually AI and public health meet, and I think it's really nice to see, you know, how all this work is really taking, you know, like the knowledge on these technologies and also the knowledge on public health. Maybe from my public health hat, I can add that, I mean, we are, most of us trained epidemiologists, so we have trained on statistics, on epidemiological methods, so it's not the user that has no knowledge or any method at all. Of course, these technologies is not that well known. So I think it's important, as you mentioned, you know, to get some knowledge on that, because otherwise we may end up having discussions on, you know, as you mentioned, I want to gather all the information, but I want to spend almost nothing of my time. So it's important to understand, you know, what is the cost of improving one of these aspects and what do we want to put more efforts. From our side, when moving and transitioning from the framework that I was mentioning and going on different platforms and moving to this EIOS platform, the good thing is that the user interface does not require the user to really understand AI, because as you saw, it's quite easy to navigate. All the information can be available. We've been discussing also how this platform can be improved, and also discussing within the community, and we are actually now evaluating the detection rate of having this tool in comparison of having the other tools, and see how this can be improved. So it has helped us a lot. I mean, of course, any new method, from history require new skills and new capacities, but I think it's really important to focus and spend a bit of time. We don't need to have AI experts in public health. We need to have public health experts that understand at least the basics on AI, and I think that's key. I always put the example when discussing with some of my public health colleagues that may have less training on these areas, and if I tell you that someone is driving a car without being able to see, everyone will understand that there's a possible risk. You don't need to understand how the engine works or even how to drive a car. So we need to reach that level so we can really have a really good interaction in this interface on where AI meets public health.
Thank you so much, and I would like also to add the fact that I really liked how Stefan touched upon the ethics, ethic-related aspects. So these new technologies are amazing. Large language models are an incredible tool, but of course, public health has to take into account the dark side, and you cannot use agnostically these tools, not acknowledging that they cost in terms of human suffering or environmental impact. And that's why public health institutions who promote wellness and prevent injuries really have to take into account these aspects. And this makes public health even more complex than anything else, because you really have to account for these issues. And the end users, so this brings me also to the next question for Roberto. In this case, we have seen how the end users can be the member states, it can be public health officials in the National Institute of Public Health, so it's not the public. And maybe there will be some time to discuss about how this is given back to the public. But we would like to know more from Roberto, how you involve really the end users to not only really use the tools and provide fine-tuning, but also have them all the way to the finalization of the product. And how are they involved in all the steps that you mentioned? Only at the end, really as end users, or in the design of what they need, the kind of information that they expect from the system, how much time they want to spend in revising all the news. So yeah, if you can elaborate more on the importance really of interacting all the way to the end with this kind of people.
Yes, that's a very important aspect. I was showing you the kind of interfaces just to give an idea about the interaction. So the interaction is across all the steps. First of all, we studied as the way the team was working for previous campaigns, like the COVID one. So we studied their reports, their decisions, the type of documents that they were reading and approving as relevant for the analysis. So we first of all started with a simple kind of autonomous steps by the machine to reproduce the same choices of the analyst. So we try to substitute the analyst. So given the entire COVID campaign, that were amounting to some thousands of news already classified, we trained the system to reproduce their decision. And these tools were learning enough well to look at the text and to reproduce the decisions. The very major point that is here focused is the coverage aspect. We need to be timely, and we shouldn't miss relevant information. So something that we couldn't study was the dark side of the moon. So the news that the team was not analyzing, maybe because of lack of resources, lack of time, you see. So the point here is to use AI not to decide, like in, for example, precision medicine, where the system is giving support to the medical doctor decisions. Here, we would like the system to read more than the analyst and provide the analyst something that has a basic probability to be relevant to them. And in the interaction, this can be measured. So what we are doing now, first of all, we try this approach and we try to see if the system was able to rediscover something that the analysts were already aware of. And so there are a couple of papers that were measuring these in terms of the typical accuracy scores, like recall precision. So the system should not introduce irrelevant information, so the system should be precise, and the system should be able to cover all the phenomena that, at least for the analysts, were relevant. This is done at a quantitative level. But we would like to start a campaign. It is starting in these days, but the ISS team is busy. So they cannot spend a lot of time doing the experiments. You know, there is a trade-off. But actually, we are comparing two teams, two sub-teams. One is using the tool, and the other is not using it. And we will measure the quality at the very end of the process by observing how good was the support that the AI tools were giving to one of the two teams by comparing the result, because this is really realistic evaluation. And I assume that we are gaining, first of all, because the analysts are not do not need to read a lot of things, because the system is filtering beforehand. There are a lot of ambiguities, as we heard. Sometimes the location of a given event is really ambiguous to be detected, so you have the news in a town, but the event is in another town, and so you are not able to assign even the geography to these events. But this is done manually by the analyst, so it's a critical situation in which the overload of information is an issue. So in order to scale up, we need the AI in place, not to decide for us, but to let the analyst, I'm not an analyst, read less. And the second point is that the AI is able to increase the quality, the level of abstraction by which the analyst interacts. Because if you are not forced to use keywords to see all the titles, and you are summarized by clustering the different events and the novelties, then I think this is a better way of browsing in this sea of information. I mean, the analyst is really faced with oceans of data and text, mostly relevant. So I think that this is a very good age, just because human beings are interfacing with technologies at a higher level. This doesn't mean that we need to move the responsibility of the choice to the technology, but we can improve the readability of the result that the technology gives us. Even today, by using Google, we are forced in bubbles, because Google is giving us a very small subset of the documents we really need, and we don't know about what we are missing. If I ask you how many of you is going to the second page of Google in the last interaction of the few months preceding this day, I think you went maybe one every 20, 25 sections with Google. This means that you are moving to Google the responsibility of giving you information, and you don't know what you are missing. This is with the today technology. It's not part of the AI problem. So from the ethical point of view, something that is more colloquial, so it's more transparent in the interaction, should give us, as human beings, aware of the fact that technology is pushing into a very small perimeter what we are free to do with our time. When I was studying AI for my thesis, I studied mathematics. I was in a bibliothèque, And I was reading the paper. I mean, I was going up and down through the books in the journal series, and I was selecting and reading and then making photocopies of a small subset after having read a lot. Today with Google, we just skip the very first 2 or 3 voices, and then we stop with the 7th or 8th in one page. This is something that did speed up our work, but is also closing the perimeters of what we know. So time is a very important aspect. And the time of the analyst can be gained by reading less of what is irrelevant and then try to focus at an high level of interaction with this ocean of data via clustering and semantic kind of naming of the events. And for what concerns the large language model, I agree totally. They are costly, they are consuming a lot of energy, and we don't need that kind of AI for everything. I mean, the algorithms that we are using, you saw the recommending of the keywords. These are done through embeddings, but with techniques that are much cheaper, and that they are very domain specific for the domain of health, and the recommendations are very sensitive because you see there phenomena that are dealing with the epidemic intelligence, and you can specialize your smaller system without using the large, gigantic large language model that we really don't need as a whole. First of all, our zero-shot learner is a large language model, not so large, because it's small, and it has been trained in Tor Vergata around a set of documents that are typical of the domain. So it is rather accurate for what concerns our application, and it's not huge, so it has an impact that in terms of energy is much, much more sustainable. So the idea is that AI is opening new way of using it, but don't see AI like the monster large language models that are just dialoguing with us. That there is no need of that when you need to solve specific tasks. And in this case, we are using different models for the different stages. The last thing it was about measuring the quality of this process with the experts. This is costly. And while the experts are working daily for epidemic intelligence in the daily life, they need to preserve some of their work for the innovative part. And this is a cost that sometimes is very difficult to achieve because the teams suffer of some limitation and they have really not enough time. But because they are so precious, because they are the humans that knows about how to do things, then, you know, in this kind of move to innovative methods, we need to invest a bit. That's a real core aspects that instead of investing on large-scale technology, we should invest in more time for our human experts that are valuable resources much more than large language models.
Thank you so much. So we reached the end of our guided discussion. I was just checking on the questions. Thanks a lot. I think we can open, thanks Roberto, thanks Stefan, for the overview on where we are all meeting there halfway. So thanks a lot for the question. We got a lot of them. I would like to maybe just start with some clarification because I see some questions going more or less on the same topic regarding data sources, how to gather data from patients, hospitals, and so on. So this is this approach of epidemic intelligence, public health intelligence, is part of surveillance and is focusing on public open sources, meaning nothing about patients, nothing about hospitals, but what is there on the website, so news outlets, social media, and so on. Of course, it's only a branch, so the data that comes from hospitals, in our case at the European level, we would have a platform that is restricted, that follows all the different rules in terms of privacy, anonymization, aggregation, in which countries will report the data that they have regarding cases or death from notifiable diseases. So in this case, this type of tool, what tries to do is, as I mentioned, during the beginning of the COVID pandemic was not actually the cases confirmed of being coronavirus or even the sequence, because that came on the 7th of January 2020. It was already in December 2019 when there was this signal, from doctors in the field, from PROMET, that was saying, look, we are seeing some cases of unknown pneumonia, all gather, visiting the same market in an area, and then also the official authorities in that area confirming that information. So that's why we want to do this approach, because if we wait for the normal process in which a person would go, and as Daniela mentioned, not all the real cases are captured, but let's imagine in an ideal world, everyone would go to your general practitioner or hospital, a test is being done, it requires time to get the results, time to process it, send it at national level, regional level, so if we wait for that, we are late. So this is a complement of kind of the more traditional surveillance. And of course, there was also a question regarding One Health. A lot of these platforms, if not all, they cover not only human health, not even only infectious diseases. So it covers all the different range. And we also have collaboration, in our case, with the agencies dealing with animal health, environmental health, also at global level, with the World Organization of Animal Health. So we have different partners that will focus a bit more on one area, but will ensure to get the contact. And by the way, some of these platforms are publicly available to the users, so you can go and have a look. I mean, of course, our recommendations is always to follow the public health authorities, because if you want to understand what is the situation about a specific disease or a specific event, those authorities would have gathered all the different information for you, process it, curate it, and communicate it in a way that you can access. So you could either try to join our team and do also the work of an analyst, but in case, if that's not your expertise, you can go to the public health authorities and they would have done that for you. So let me go back to the question. I don't know if you want to start asking some of the questions.
Sure. So thank you so much. We are receiving many, many questions. Many of them are super interesting. I would say all of them. It means that the discussion has been simulated, so we're really happy for that. The most popular question at the time is quite interesting, and it's about limitations and bottlenecks. What are the bottlenecks in using AI for the benefit of public health? It can be data, it can be technical stuff, or general understanding. So maybe we can elaborate more on what is, what are the challenges limiting the adoption of AI in public health. And I don't know who among our guests want to start.
Yes, thank you very much. I think it goes to one point I find very interesting is use AI to do what? So we have that. Of course, many people said we need to be innovative, we need to use AI, but to do what? So of course, there are typical use cases. So I think what Roberto just said, the time of the analyst, right? So our users, they are already running after the event. They are already exhausted, if you wish. They are never. So here again, if you have comments, recommendations, so to interact in a way that is non-invasive in a way with the users, because for me this is the main challenge, also because we don't have this culture again of product development. So for instance, one thing we did is, I thought maybe we do long interviews in groups, and then a UX UI designer said to me, no, you don't do that. It's much we don't do user groups. You do short interviews, they show you how they work, 10 minutes follow-up question, that's it. They don't prepare anything, and they just tell you. And then it's your job to analyze that. So, that's the one thing that we are always, even in this, we are preparing for epidemics and pandemics. And by the way, I hope you all know that the last pandemic was not COVID. That, of course, you know, but I'm sure that many people here have not, I see, it's Mpox, which was declared the latest, and was also the end of the Mpox pandemic was declared officially by WHO after the end, a few days after the end of the official COVID pandemic. So we are already after the second pandemic after COVID, right? And we know there are many that will come more. And getting this preparation and having the people who know best available, as you mentioned, this is one of the big challenges. There's the know-how. So here, of course, there's a lot that's represented, but it's very tough to get to you people to work with us and develop with us. So that's why we're here as well. And yeah, I guess that's it. The data are indeed difficult because, at least for us at WHO, I think for you, CDC, it's a bit the same. The countries, it's different. We don't own much data, actually. So we coordinate, we propose tools, but the data, they don't belong to us. And as I said, they are very diverse, some are sensitive. So this is an issue as well. So it's my hope also that we can propose tools that are adopted by the communities. But again, this means many different communities with many different needs there. So yeah, I guess for me, that's where I see the challenges. We can rush ahead, and we have experimented, you know, in a few days, you can go up and have a RAG there, but to make it sustainable and useful, this is more challenging. Thank you.
Yes, I basically agree. I just had the general understanding of the process because, you know, people that come from epidemic intelligence knows a lot of statistics, quantitative methods that are scientific methods by their own. But the variety of different tools that the AI can give you is quite large, is not concentrating on the idea today that everything is machine learning. So data are very relevant, but for example, in our case, a very big challenge in Italy that I experience with medical data is that they are not interoperable across system because every organization and every institution has its own information system that was pushed by the market. I mean, industries were rushing to produce information system for hospitals, but the kind of standardization of the information is quite poor. Most of the information is basically kind of administrative information, and the real core of information for, let's say, clinical evidences, pathologies, therapies, is written in different ways in different information systems, and you have not a coherent way. So part of the game of AI is not interacting via dialogue with people, but is reading and try to distill the information and standardize. I think this is underestimated. I mean, a lot of work should be done by AI, by looking at the data, trying to make a link between the high-level concept we need, the epidemic intelligence analysts need, and the documents that are full of information. And the news are just one phenomenon, but I think that the clinical notes are a nightmare, because everyone is writing them in different way, formats are different. So a very major bottleneck is the incidents that the public organization can have in making all this information that is a huge asset for every country, but is largely unexplored, is just used for administrative purposes. At least in Italy, they are very confident to assign a code to a pathology to get the money from the Ministry of Health because the hospital is paid on the basis of pathologies that have been taken care of. And so this has been the triggering factor of the information system in medicines, and nothing about health-related sciences. And this is, to me, is very important. And second is also the background. We don't need to be expert in AI, but when you do AI, you are not doing statistics. You are doing modeling, you are understanding your domain, and the modeling of a domain for machines, that is a typical computer science background, is very important. Usually is underestimated, even in scientific environment, where people ask the model that come from the science, like physics. You have the model in advance, and then your data are just a transcription, numerical transcription according to the model. But in qualitative areas like medicine and other areas, we don't have quantitative models a priori of the phenomena, but the phenomena are manifesting in very qualitative fashion, and they have some principle, and from the data, to this principle, there is a gap that we call interpretation, done by the medical doctors, by the analysts, and the other experts. So the domain expertise of this system is part of the game of AI. And is partly due to the data, because without data there is no model of the data, but is also part of the design stages that the domain knowledge require. So to me, one of the bottlenecks of the introduction of AI in the different environment is this salvific. Is there salvific? I don't know if it is, it's very Italian. It's this kind of positive view of the data, like the data that comes with their own meaning. But there is no meaning without interpretation. We know this in linguistics very well. So first of all, AI should be injected when you are aware of what you are modeling. And this is a scientific process that is still in the hand of the domain experts.
Yes, maybe to stress that also, I think one of the challenges I see is saying AI is not a data science issue first and foremost. Today, when we ask what do we do with AI, I think these are for the domain experts to tell us, what they can do with that. And I think here it's a challenge for me to first start, okay, I can look into it, but I shouldn't be as a data scientist or quantitative expert, data analyst, the first one, to look into it.
Thanks a lot. So I see another most voted question. The second one, I will read it. I'm a mathematician turned epidemiologist working in AI in public health. How can you ensure that advanced research can be used and translated for policymakers? So maybe I can start a bit here. So we need to understand that I'm a public health veterinarian by training, and I always say we are different animals among ourselves. So we need to understand what is the behavior, how each of our, us as animals will interact. And that's important because, policymakers, first of all, they don't have time and they want results. So if you want to use all this data and research that is being produced in academia and other sectors, you don't have 15, not even 20 minutes to go and explain all the methodology and how it works. Because sometimes they will have 2 minutes, they will have their own minister asking them. So we need to be sure to translate the information. I think one key aspect that is really important is that when research is made publicly available, and you can really explain what is happening behind. So from a public health perspective, and especially from decision makers, we cannot say, well, the system we use decided to do A instead of B, and then if something happened and it should have been B, the consequences can be huge. And you cannot just hide yourself saying, oh yeah, the accuracy was 98%, it was almost perfect. But what is that 2% meaning? So I think, at least from my side, and I will give maybe the floor to our guest speakers here, it's important, first of all, to understand the audience, focus on what can we explain, and then not going only for the most complex solution, because explainability, it's key. I mean, we had a lot of talks and workshops during the weekend and yesterday also on the new regulations coming on AI. So we need to ensure that we can explain what we are doing. And as has been said, maybe we don't need a large language model to give us the solution. Maybe a simple decision tree would be enough. And that can be easily explained, in a decision maker or anyone in one image. Why is going this result and what would have been the difference to go to a different result. So I think that's quite important to keep in mind when trying to bridge the gap between the research that is being done and the usage of these technologies by decision makers or policymakers.
Just comment. And to add the complexity to that, it has to be remembered that it's not public health officials that take decisions. It's not up to them to decide what to do. Usually in a public health institution, there is the research component, the evaluation component, but not the decision component. And so, especially when it comes to proposing scenarios and communicating aspects related to uncertainty, this has a probability X of happening. These has another probability of happening if you do this and this and this, then it's up to, unfortunately, politicians, to the Ministry of Health to take a decision based on what public health presents. So we not only have the challenge of gathering all the information, having explainable models that also include some AI, so they might have these black box component, but we also have to communicate the uncertainty. I'm not telling you that if you vaccinate 90% of the population, the disease will go away. This is not what I'm telling you, but this is what politicians want to hear. And so there is this huge challenge of communicating the results of complex data plus models interactions, and having the politicians to take decisions based on resources available, time available. And so it's really a very complex situation, and I really would like to stress the fact that public health is not in charge of decisions, but they are the ones who eventually can be blamed for wrong decisions by politicians. So, and then we'll
yeah, maybe because I see we have 5 minutes, so if that's okay, I don't know. I mean, there's a lot of questions. We also have the possibility, and I will encourage our guest speakers to go and reply the questions, or you can also approach us directly. But is there any question from the audience that someone would like to ask, or even if you have posted on the Slido but we haven't replied, maybe to give the opportunity if someone wants to just stand out and ask. Yes? One second, the mic is coming.
Thank you. You talk a lot about like public health, targeting human. I was wondering how it can be extended to the concept of One Health and then integrating animals, vegetables, all in one instance.
Yes, thanks for the question. So I can give you maybe a concrete example. So in the European Union, we have different agencies dealing with different aspects. So the European CDC is based in Sweden, and we deal mainly with human disease. There's an agency in Parma, in Italy, that deals with animal health and food safety. So we are in connection with them. So the way it works is that we will focus on gathering information from different sources. If we find, for example, a signal that there was some human cases that got foodborne poisoning, and then we find additional information from the possible source, we will share that with our colleagues in this agency on animal health and food safety, in case they are not aware of that information, so they could follow the food tracking and tracing to see what is the case. In terms of global level, there's the World Organization of Animal Health that they do also epidemic intelligence activities, so we communicate with them as well. So the idea is that we will have different players from the One Health, and then each of us will try to focus more on what our knowledge is a bit better and ensure that we will communicate. Because if we want to cover all, well, in my case, I'm again, a strange animal and a veterinarian public health. So I've been dealing with human health, actually, from the beginning. So I have some knowledge, on also animal health and food safety. But in this agency, that was not the primary objective to be there. So in order to be consistent and to cover all the aspects of One Health, the key thing is communication, and to ensure that all the different players, like human, animals, environment, and, like also groups like what Stefan was mentioning in the hub, because we also need data scientists, tools, are all together, because otherwise it would be impossible that one single institution will cover all of that. So as I say, I presented more on what we are doing on human health, but at the end the process is the same. We will follow the same sources, maybe some of them will change. Also, we have similar restricted platforms. There's one for the incidents in food, not only for allergens, but also, not only for pathogens, but also for allergens, mislabeling. There's one for human, there's one for environment. So we have kind of replication of the different aspects or blocks of the surveillance in the different branches of the One Health area.
Yes, thank you. Maybe on that, I think also this is where AI could help bridge traditional disciplines, right? So you have veterinarian, human health, environmental health, and the organizations are different, and this coordination is difficult. And maybe AI can say, oh, for you, given your job, this might be interesting for you. So I think this usage, not tell me what I should know, but tell me what I might have missed. I think there's a use case also for the kind of large language models that we are discussing.
Thanks a lot. I think shall we go for one more?
Just one more. I think the one that was really interesting is the underrepresentation of possible population through these digital traces. Of course, this is a big, big issue. And I don't know if any of our guest speakers want to comment on that.
Sorry, just to say, really complex topic, 1 minute. So, challenge for you.
We noticed, for example, that at the beginning the team was working with a subset of the major newspapers, and they had some problems with the local newspaper that were very interesting in the small communities across Italy. So we, and they were somehow underrepresented in the Google searches or Google topics. As you saw, some of the numbers are derived from the ability of Google of covering all the news. So we have been stipulating with the team a list of Italian newspapers, and we go for direct crawling to them. And the ability of going there and filtering is the ability of the system of deciding what's in there and is possibly of interest for the specialist. So having AI deciding where to go and what to filter out is a very strong and powerful method for dealing with underrepresented phenomena that otherwise are outside the Google bubbles.
Thanks. Just also briefly to add, we are dealing here with online sources. There's some work that is trying to develop, like offline sources. So, for example, radio. There are in some areas of the world that communication and information will be shared, through radio and like offline channels. So we are starting also to explore in there, for example, AI, like from audio to text could really have a big impact. And of course, we need to ensure that this is only one of the branches. We cannot forget that usually vulnerable population will be less accessible to this type of platforms. So we also keep the traditional, let's say, communication, reach out to these communities, giving safe spaces where they could go, for example, talking about HIV, where people could go and get tested without having to be kind of seen and so on. So I think it's really important to keep in mind that it's only a subset, and we are moving little by little also towards other sources in which AI could help to go from the offline discussion to make it easier for the analyst to screen.
Yes, maybe just to conclude on that, I think it's again this involvement of the communities there, the key that they tell us. So in Italy, you know, but worldwide, that we really need to go and have this. This is why also it's a difference between WHO and other organizations, that all member states are equal to us. So that the smallest ones, they have the same mandate as the largest ones, right, and they can tell us, for me, this language, this source is important. It's not everything, of course. If there's no digital trace, we cannot find it at the moment yet, but the radio is one aspect. But again, we care for the communities locally, that they tell us what works for them. Thank you.
And the last thing I would like to add is that AI can also help uncover who we are leaving out through these digital traces. So, for example, based on population distributions or other more traditional data, in comparison with digital data, we can see who is being left out by, for example, Facebook maps or these kind of approaches, and through really AI methodologies. So we basically can have a whole set of tools to re-include who's been left out. So with that, I think we will conclude the session, and we really thank you, our speakers, and you for being with us. The many questions we received means that there is a lot of interest for this topic. So I think we can promise we can be back next year and have additional discussions, because it's a really frontier, the frontier that we really want to push forward and have more experts come in from both sides. We really want both sides to become more interactive, and so I think there is a lot of room for additional work.
Yes, so thank you, everyone. I say there's still some questions there, probably not answered. We will have a look. Maybe we can answer them through the QR, through the Slido, but also feel free to reach us. And thanks again, because a track is only successful if we have great speakers that we had here, but also great audience and interactive. So thanks a lot.
Thank you.